The pressure in the water depends on the depth. The deeper you go, the greater the pressure. The formula for calculating this increase in pressure goes like this. Say you have a point down below, yes? I'm going to call this down here point 2. And let's say you're comparing that to this point up here on the surface of the water, point 1. Well, the pressure at the lower point turns out to be equal to the pressure at the higher point plus the density of the fluid you're in this case water, times the acceleration due to gravity, times h, where h is the depth that you're at. And in this problem here, you're at 5.50 meters. So if you wanted to figure out the pressure down at this lower point in the water, basically the pressure at this lower point would be equal to the pressure at the top right here. Well, the pressure at the top right here is atmospheric pressure. So the pressure at the top there is going to be 1 times 10 to the 5th pascals plus the density of the fluid, in this case it's water, so that's going to be 1 times 10 to the 3rd kilogram over meters cubed times the acceleration due to gravity, 10 meter per second squared, times the depth, 5.50 meters. And can I get a little help with that calculation? Equals 15530, 155,000 pascals. So basically, what do we have up here? Atmospheric pressure, surface is 100,000 pascals, and down below, down over here, the lower pressure is 155,000 pascals. Now, here's another interesting point I want to make. Notice if you scoot it across over here, this point right here, it's at the same depth, but it doesn't have water above it. See, there's like this little bit of land right here. It doesn't matter. If you figured out the pressure here, that would be the same as the pressure here, as the pressure here, as the pressure here, as the pressure here, as the pressure here. Because remember, pressure is not a vector quantity. The force on every single face of that cube was in every single direction. So it was a sideways force as well. So the pressure here equals the pressure here. And then from this depth, if you went down, using the same formula, you would get the same lower pressure as you got right here. So the pressure here, let me highlight that, and the pressure here would be one and the same. And the pressure here and the pressure here would be one and the same. It just depends on the depth from the surface. All right, well, let me clarify that. Okay. The P2 here is the lower point's pressure. The P1 here is the higher point's pressure. The rho here is the density of the fluid. The G is the acceleration due to gravity. and the h is the depth at which you're taking the pressure. So that's the depth of lower point.